Hi, in the previous class we have seen about the designing of chemical synthesis. What are all the aspects to be taken into consideration before going for a synthesis? One among the principles of green chemistry which talks about the energy conservation. Alternate sources of energies are to be considered. So, in today's class we will see how microwaves are used to bring about chemical reactions. That is about microwave assisted synthesis. Before going into the synthesis, how microwaves can be used, what is the mechanism behind that, and what has been understood with the microwaves, that we will see in this class. Before going into the synthesis, first let us see what are microwaves and how microwaves are used to carry out the chemical reactions, and to what extent we have understood the microwave assisted synthesis. The application of microwaves in the chemical transformation was first brought about in the year 1986. Now, the microwave assisted synthesis has emerged as a new green tool for the synthesis of organic compounds. As the knowledge of understanding is increasing, new areas are being explored to use the microwaves. What are microwaves? Microwaves are electromagnetic radiations. What are electromagnetic radiations? The electromagnetic radiations have two different parts. One is the electric part, the other one is the magnetic part. These two parts, that is, they are perpendicular to each other, and not only perpendicular to each other, they are perpendicular to the direction of propagation of these waves. So microwaves, these are electromagnetic radiations which range from 1 centimeter to 1 meter wavelength, that is 30 gigahertz to 0.3 gigahertz radiation. Now let us see how these microwaves can be used to carry out chemical reactions. Normally a chemical reaction in the sense either bond breaking or bond making has to take place. So it involves bonds. So let us discuss about ionic bond, covalent bond, coordination bond, and hydrogen bond which prevails in these compounds. What is an ionic bond? How it is formed? When an electron gets transferred from one atom to another atom, it results in a cation and an anion, and the force of attraction between these two ions is called ionic bond, and the energy of this bond is 7.6 electron volts. The other type of bond, that is the covalent bond, it is formed due to the mutual sharing of two participating atoms, and the energy is approximately equal to 4.28 electron volts. The third type of bond, that is the hydrogen bond, wherein an hydrogen atom is placed in between two electronegative atoms, and the energy is approximately equal to 0.04 to 0.44 electron volts. So this being the average energy of these bonds, let us compare this with the Brownian motion, which is having an energy of 1.7 into 10 power minus 2 electron volts, and the energy of the microwaves where it is 2.45 gigahertz and approximately equal to 1.6 into 10 power minus 3 electron volts. So if you see all these things, the energy of the microwaves is very less. Then how microwave photons are not able to break even a hydrogen bond can be used to carry out a chemical reaction? How it takes place? So normally, that is, the substances, they may be in the gaseous state, solid state, or in the liquid state. In gaseous state, the molecules are far away from one another, so there is no intermolecular attractive force. So when a microwave is passed through a gas, these gaseous molecules cannot interact with the microwaves. Whereas in the case of solids, the molecules are too close, they are tightly held together, so they also cannot interact with the microwaves. because in the microwaves there will be alternate oscillating fields. With this, the atoms cannot move here and there. But in the case of liquids, where the molecules are neither far away nor nearer to each other, that is, it gives a favorable condition for the microwave assisted synthesis. So in these cases, even the substances is in a favorable state with respect to the energy of the microwaves. If the energy of the microwaves is very high, what happens is it will rapidly oscillate, and the molecules, they may not be in a position to cope up with this oscillating field, so they won't move here and there, so they won't respond to the microwaves. Whereas in the case of low microwave energies, the reorientation of the molecules is very slow. So in both these cases, if it is too high or if it is too low, the molecules cannot respond to microwaves. It won't result in a chemical reaction. But if the microwaves are of frequency 2.45 GHz, that is the optimum frequency, which is in between the other two extreme cases, and these waves are used to bring about a chemical reaction. So this is not a property of an individual molecule, but a collective phenomenon of the bulk. And being used, the substances, there are two types of molecules. Either they may have a polarity or they may be nonpolar molecules. Once again, if they are nonpolar molecules, they won't interact with the microwave radiation. So a reaction has to take place in presence of microwaves means the molecules has to be polar. So they can reorient, they can align with the field, and they can respond to the microwaves. Now let us see the mechanism behind how microwaves can bring about a chemical reaction. That is, when microwaves, when they fall on the substances to be reacted, these molecules, they will respond to the microwaves and they will align in a direction of the external microwave field. When we alternate this field, slowly the molecules also, they will reorient themselves and they will turn in the direction towards the microwaves. So in this process, the to and fro motion, it will happen to the molecules. As a result, they will collide with each other and heat is produced. So this heat, it will cause the rise in temperature, and that temperature can be used for breaking bonds and for making bonds. As a result, the chemical reaction takes place. So while they move, the potential energy gets converted into kinetic energy, and the kinetic energy automatically converted into thermal energy. As a result, the heating takes place. Now let us see what is the broad differences between a conventional reaction and a microwave assisted reaction. In a conventional reaction, what happens is, when we heat the flask, the reactants which are present in the bottom of the vessel, slowly they will pick up the heat and it gets transferred along the bulk solution. So as a result, the local heating will take place in one side. Not only that, the flask gets heated up. But whereas in the microwave assisted synthesis, the microwaves directly it goes into the bulk solution. The molecules, all the molecules, they will respond to the microwaves and heating takes place simultaneously each and every point, and as a result their heating takes place. In this case, the temperature of the vessel is also very, very less. So heating taking place only in the bulk solution, sometimes it gets superheated. Even solvents will be heated to a higher temperature than their boiling point, and at a higher temperature the reaction takes place faster. Now let us discuss about the reaction rate acceleration effect. That is, the reaction time is reduced from hours to few minutes when assisted by microwaves. Under microwave irradiations, high and intense temperature can be achieved very quickly, and the liquids are also superheated. In this case, if the vessels are made up of Teflon or polystyrene, these two materials, they won't respond to microwaves. Only the substances inside will respond. As a result, the vessels will be cooler and the superheating takes place inside it. So let us take the Arrhenius equation, K equal to A exponential of minus delta G naught by RT, where K is the rate constant, A is the collision frequency or Arrhenius factor, delta G is the change in free energy, R is the gas constant, and T is the temperature. What we know from this equation is when temperature increases, the rate of the reaction increases. So that's what it is taking place in the microwave assisted synthesis. That is, the temperature inside the liquid increases, as a result the rate of the reaction increases, and that is the reason why the reaction time is reduced from hours to minutes. And not only this factor, the molecules, when they respond to the microwaves, they will move from one direction to another direction. So when they move in this fashion, the probability of collision is much more. And once again, when we see the Arrhenius equation, the term A, which talks about the collision frequency, that is, the collision frequency in the microwave assisted synthesis is more. So once again, that contributes to the rate constant K. So as a result, the rate of the reaction increases. So here not only the reaction time is less, here inside the vessel we can increase the temperature. Suppose if we have two different materials, and if the solvent doesn't respond to the microwaves, and one of the reagents, it responds to the microwaves, then the superheating can take place only with a reagent. The surrounding medium may be cooler, but intensely the reagents will be heated, and that can be used to carry out the chemical reaction. So put together, the microwave synthesis, the atom economy increases. That is, it gives more yield and as a result lesser wastage. It gives a cleaner reaction conditions, that is, less byproducts, so lesser purification burden. And not only that, we can use green solvents like water and ethanol for the chemical reactions, and they are reusable. And the quantity of the solvent required may be less, say 0.5 to 5 ml per reactions can be used. Further, it requires a very low energy input, 50 watts or maximum 300 watts, and easily we can switch on and switch off the microwave assisted synthesizer, so control becomes easier. The derivatization may be reduced, use of blocking agents may be avoided, protection and deprotection steps may not be required in the microwave assisted synthesis. So it leads to rapid reactions, so a rapid method development. So these are all the advantages of using microwave assisted synthesis. And so far, that is, we have seen what are microwaves, how it gets generated, what is the mechanism behind how it can bring about a chemical reaction, and what are all the advantages in using microwaves to bring about chemical reactions. So to conclude, so microwave heating techniques, it leads to a simple, one pot, clean, faster and an economic method for the chemical reactions. So it is the future of the technology. So we can say it is an hammer in our toolkit and all the problems appear as nails. Let us come to the end of this session. Hope you understood about the advantages of microwave assisted synthesis to bring about the chemical reactions, and in the upcoming sessions let us see the different types of microwave assisted synthesis with suitable examples. Thank you.